All right, hello everybody. We're going to do 5.3 log functions and their graphs. So your entire front page of notes I'm going to save to go over in class. So go ahead and skip to your second page. And we're going to start with converting between exponentials and log functions. So I'm going to give you a log function to start, and I'm going to give you some colors that may make it a little easier. So any log function is always going to be y equals log. They're going to have their own individual bases. So that's going to be log base A of x. So those three different colors are how we're going to switch from a log to an exponential equation. So if I give you a log and you need to write it in terms of an exponential, just follow this pattern. You're going to take that base, that A, and you're going to raise it to the y value and set it equal to your x value. So anytime you're converting from a log to an exponential or an exponential to a log, just follow that pattern and just be careful that you're pulling out the right values. So example 2 here, we're going to take all of these exponentials and we're going to convert them to logs. So looking at this one over here, that looks pretty similar to this guy right here. So I'm going to just use those colors to show. So 16 would be our green x. 2 would be our base A, and that's being raised to this blue y value. So if it's helpful, you can convert those with colors. And then I'm just going to write it in terms of the log. So this is going to become, oh, sorry, that was an x up there. I couldn't see it. So this is going to become x equals log base A, which is 2 of 16. So that original A, 16 equals 2 raised to the x power, is written exactly the same in log form as x equals log base 2 of 16. So they're equivalent to each other, they're just written in two different forms. On this second example, this should be 10 raised to the negative third power, not negative 13, so just change that for me. When we're writing this in terms of a log, this is going to become log base 10 of 0.001 equals negative 3. And then on this last one, log base E of 70 equals t. So really just following that pattern between logs and exponentials. And then in example 3, we're going to take all of those logs and rewrite them as exponential functions. So you should still have your notes out. You can kind of look at that pattern that was originally up there. This first one's going to become base 2, so 2 raised to the 5th power equals 32. Second one, a to the 8th equals, maybe my board stopped writing. There it goes. A to the 8th equals q, and on this last one, t to the x equals m. So really just practicing understanding how to go from a log to an exponential and from an exponential to a log. So we have something called a common log. Log base 10 is just referred to as log. So if you don't see a base, you're going to assume that it's 10. In your graphing calculators, your calculators can only do base 10. So when you press the log button on there, it's assumed that you are in base 10. So on your graphing calculator, go ahead and find the log button and then type in log of 645,778. And I'm just going to give you the answers. Check, make sure you get these. On C, you should get an error. That one is a no solution. We can't take the log of a negative number. So pause that, make sure you can press those, find those, get the same answers. That's your common log. That's the button you'll find in your graphing calculator. A natural log is log base E. If you ever have log base E, we can write that as a natural log, which is just ln. And you'll find ln on your graphing calculators. It is unique, it's special, so just make sure when you're in log base E, use ln instead. And again, find that value or find that button on your graphing calculator. ln, type in that 645,778, and make sure you get these following values. Again, on the natural log of -3, you'll get a no solution because we can't take logs or natural logs of negative numbers. The natural log of e is 1. The natural log of 1 is 0. So that's just your graphing calculator. Make sure you find those buttons. Make sure you get those answers. And then just as a note down here, you cannot take log or natural log of a negative number. All right, we've got what's known as the change of base formula. So your graphing calculator only has the log button, which is base 10, and the natural log button, which is base e. You don't have any other buttons that are going to give you other bases. If you have a fancy graphing calculator, I will show you in class how you can find different bases. Some of you won't, and you have to use this method. So let's say I give you log base b of m. And base b is base 2 or 4 or 7, but it is not 10, it is not e. So it's not something you can just press log or natural log in your calculator. Then you have to follow this formula. You're going to take log base a of m divided by log base a of b. And that base a can be 10 or it can be e. So example 6 and 7, I'm going to write this first one using a common log. And remember, common log is log base 10. And then on the second one, we're going to use natural log, which is log base e, which we write as ln. So I'm just going to use the formula listed above. The first one, common log, the second one, natural log. So this would look like log base 10, I don't need to write it, of 8 divided by log base 10 of 5. On the second one, it would be the natural log of 8 divided by the natural log of 5. Now, in your graphing calculator, make sure you use your parentheses to make sure it understands, or use that alpha y equals button so that you actually get a fraction in there. On both of these, you should get 1.2920. So make sure you can type that in. This is if you have an old school calculator. If you have a new calculator that can actually do different bases, and you can literally just type in log base 5 of 8, I'll show you how to do that in class on your calculator, but not everyone can, and if you cannot, you have to use this change of base formula. And I'm going to save graphing logs for in class, and I'll just do one more example with you on the last page. So we're going to go to this application problem. It's a pretty straightforward plug and chug, but I want to make sure that you understand it. So pause and read through this problem. They're giving us this equation or this formula. So walking speed of a population is equal to 0.37 times the natural log of our population plus 0.05. And they're telling us the population of Billing, Montana is this 106,000. So we're just plugging in that number. So we know that 0.037 times the natural log of 106,954 plus 0.05. Plug that carefully in your calculator. Make sure you use parentheses. You're going to get about 1.8. And walking speed, they told us, is in feet per second. So in Billing, Montana, people walk about 1.8 feet every single second. And then if we want to know the same in Chicago, Illinois, they're giving us a different population. So using that same formula, 2714856. Again, plug that in your graphing calculator. You should get out about 3.0 feet per second. So in a more populated area, we're going to find that you're going to walk faster. You're going to cover, not necessarily faster, but a bigger distance over